Hey guys, welcome back to Level 6 Math. Today we're going to do Saxon Math lesson number 58 on probability and chance. Now, the underlying principles for this lesson we've covered before, so this is going to seem like a little bit review because mathematically it is review, but we're going to do some word problems and do this in ways that we haven't done before. And honestly, this is one of the harder lessons just because we're going to cover a lot of different things when it comes to probability and chance. Go through a bunch of examples with you, but this is a little bit of a longer lesson today. So we're going to take probability and we're going to talk about how likely it is to occur or not occur. And we're going to do that in fractions, decimals, and percentages and convert those over. That we've all done before, but we're just going to talk about that a little bit more today. So in our world of uncertainties, we say things like, what's the chance of rain on Saturday? Or what are the odds of winning the game? Or what's the probability I'll roll a number needed to land on the winning space? So this is a study of probability that helps us assign numbers to uncertain events that compare the likelihood of whether or not those events will occur. We do this all the time. So this happens in a betting world. This happens just in predicting certain things when it comes to weather or other things. Even in your own like setting goals and things, you can think, how likely is this desired outcome to occur? So we use probability and chance all the time. The goal, especially from a mathematical standpoint, is how do we make that probability and chance as mathematically feasible as possible? And we'll talk about that a little bit later on. So events that are certain to occur have a probability of 1. And those that are definitely not going to occur have a probability of 0. Everything else is somewhere between 0 and 1. And we can think of that in terms of percentages. So it's a 25% chance, or in decimal, 0.25, or in fraction, 1/4 chance, right, in that example. So if a number cube whose base is numbered 1 through 6, the probability of rolling a 6 or less is 1, because all the numbers are either 1, 2, 3, 4, 5, or 6. The probability of rolling a number greater than 6 is 0, because there is no number greater than 6 on a number cube, which is, I don't know why they call it number cube, a dice or a die. Events that are uncertain to have probabilities that fall anywhere between 0 and 1, the closer to 0 the probability is, the less likely it is to happen. The closer it is to 1, the more likely it is to happen. And we can put that on a scale. So this is called a range of probability. 0 means it's not going to happen, 1 means it's definitely going to happen, and somewhere in between it's unlikely up to half or 50%, and more than 50% it becomes more and more likely the farther you go on the scale. So in this lesson we're going to practice assigning different probabilities to specific events. So this is the new thing. We haven't really applied these probabilities to specific events. The set of outcomes is called a sample space. And we're going to write sample space with this little squiggly parentheses or bracket. And this is going to be important. We do this when you get into college. You're going to do statistics, and they're going to ask for a sample space. And you're going to have to set it up like this. So we're doing right now, the stuff that you're going to do later on in more advanced math. But sample space just has all the likely outcomes are set within those two braces. All right? Using abbreviations, we can identify those. So if we're rolling a die, for example, or not rolling a die, flipping a quarter, we can get heads or tails. And if we have 2, it could be heads, 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 tails, tails, heads, or tails, tails. Those are the 4 possible options that you could get if you rolled, or if you flip 2 coins at the same time. There's only 4 possible options. That's our sample space. Now, if we're spinning something, our sample space is going to be a little different because look, are these all equally weighted? No. A is 50% chance, while B and C are 25% chance, or 1/4. So if this was divided into 4 parts, this would be 2 of the 4 parts, 1/4 and 1/4. So what's the sample space for this experiment? And are the 3 outcomes equally likely? Well, the sample space is just A, B, and C, but A is twice as likely. So we would say that's 2/4, while as B and C are 1/4 each. All right? So the probability is the fraction of spins we expect to have. So in sector A, because it takes up 1/2 of the space, the probability is 1/2, 0.5, or 50%. Whereas the other two are going to be 1/4, 1/2 of 1/2, which is 0.25 or 1/4 or 25%. So the probability that the spinner will land in sector C, since B and C are equal in size, we know that the spinner is certain to land in one of the sectors, so the probability of all three outcomes has to add up to 1. So 1/2 plus 1/4 plus 1/4 equals 1, or 0.5 and 0.25 is 1, or 50% plus 25% plus 25%, they all equal 1. You have to do that with your sample space. If it doesn't equal 1, then something's off, and that's how you check your work in these kind of problems. So Meredith spins the spinner shown 28 times. About how many times can she expect the spinner to land in sector A? Remember, that's the one that was 1/2. And so all we have to do is multiply 28 by 1/2. So 28 times 1/2 is the same thing as dividing by 2. 28 divided by 2 is 14. So 28 divided by 2, 14 times. That's how likely she is. Now, B and C are both half of that, so we can just take 14 and cut that in half. And then we know, does 7 plus 7 plus 14 equal 28? Yeah, so it checks out. So B is going to be 7 times. C is also going to be 7 times. It'd be unlikely for the spinner to never land in sector 8 in the 28 spins. It's actually going to be 50% chance every time, right? And so that's when we put the percentages on. If we'd say it's a 50% chance, right? We'd say that instead of a 1/4 chance or a 0.25 chance or whatever. So we'd say it's a 25% chance. All right, let's go ahead and move on to the example 2, which is a similar one. The weather forecast says there's a 60% chance. All right, so now we're talking in percentage, that's chance. What does that mean in terms of decimals and fractions in raining tomorrow? Well, we're just going to convert 60% to a decimal or to a fraction. We've done that before. We just haven't talked about it as being a chance, right? So we're going to take that 60%, 60 over 100, that reduces to 6/10, which reduces to 3/5. So it's a 3/5 chance. That's the same as 60%. Or as a decimal, 60 over 100 is just going to reduce to 0.60 because we've got the 2 zeros on 100, so we've moved the decimal over 2 times, 0.60. All right. So the probability can be expressed as 3/5, 0.6, or 60%. Usually we would say 60%. All right, the complement of an event. This one, we've talked about complements once before when doing angles, and a complement is the opposite of the event. In an angle, it was you add the two angles, the complements, and it equals 180 degrees. Here, a complement of an event is the opposite. So the opposite of event A is not A. Now, you know, the probability of rain before it was 60%, so the complement of that would be the opposite of 60%, which isn't negative 60%. It's what would equal 100%. So we subtract the 60% from 100 and get 40%, which reduces, if we did it the same way we did with 60%, that's going to reduce to 2/5 or 0.4. So I'm just going to go through that quickly. 2/5, 0.4. So the probability of an event and the probability of its complement, if you add those together, that's going to equal 1. All right, in some experiments or games, the outcomes all have the same probability. Like if you flip a coin, 50% head, 50% chance of tails. If we roll a number cube, each has a probability of 1 in 6 because each side has a different number, 1, 2, 3, 4, 5, or 6. So that's a probability of 1/6. To find the probability of an event, we simply add up the probabilities of all the outcomes that make up the event. And if all the outcomes of the event or game have the same probability, then the probability of the event is the number of the outcomes divided by the number of the possible outcomes. Which seems kind of confusing. Don't worry about it too much. We'll get into some problems that'll make more sense. So if a number cube is rolled, again a 6-sided die, find the probability of the upturned number being greater than 4. Now greater than 4 doesn't include 4, so really the only numbers we're looking at are 5 and 6. So that's 2 possible outcomes out of 6. So that's going to be 2/6, which reduces to 1/3. Then find the probability the number is not greater than 4. So not greater than 4 would include 4, so it'd be 1, 2, 3, or 4. That's 4 out of 6, or 2/3. So we take our sample space, which all possible outcomes, 1, 2, 3, 4, 5, 6. 2 of them are greater than 4, so that's going to be 1/3. And then 4 of them are going to be 4 or less, which will be 2/3. We add up 2/3 and 1/3 the complement, and it equals 1, so it checks out. Okay, that's it on that one. Example 4, these are the kind of problems you're going to see on the test. They trick a lot of students up, so let's focus on example 4 here for a while. A bag contains 5 total red marbles, 4 yellow marbles, 2 green marbles, and an orange marble. So to get our sample space first, we have to just think how many total marbles are there and what color. So we're going to have red, yellow, green, and orange. And 5 plus 4 is 9, plus 2 is 11, plus 1 is 12. So a total of 12 possible marbles in those different colors. So without looking, Brennan draws a marble and notes its color. What's the probability of drawing red? Well, there's 12 total, so that's going to be our denominator. Let's go ahead and draw this one out. 12. And how many total are red? 5. So he's going to have a 5/12 chance. What's the complement of this? Well, subtract 5 from 12, and that's going to be 7/12. We know that's the complement because 5 plus 7 is going to be 12. And what's the probability of the complement? So that's just going to be 7/12 chance, right? Which we could convert to a decimal or a percentile. I don't think they really want us to here. So we're going to come to the possible outcomes, 5/12. Then we're going to subtract that from 1, which gets us 7/12. So the probability is not 7/12. And what's the probability the marble draws is a primary color. So we have to go back to the problem. And we'll just add up. Primary, remember, is red, yellow, and blue. So red is 5, yellow is 4, and I don't see blue. So that would be 0. So 5 plus 4 is 9. 9/12 will just reduce that. So our probability is going to, 9/12 reduces to 3/4. And that's what we get for our probability there. All right. And I guess that is it. So we'll practice looking at probability and chance today. A lot of word problems here. It's a little bit challenging, so don't worry. We'll practice. We'll go over this several times. Just do your best. Thanks. Bye.